All right. So I want to believe that every time we've started a new section, new chapter, mainly a new chapter, when you see that term up there, okay, what is it that comes to mind when you see everything, not the human A&P, but the cardiovascular system? What, if you had to explain that as short as you could, what would that possibly be? Okay. The heart. Can we be a little more specific with that? Yeah. Because that's just part of it. Because some of you, lifeguard, right? And I can't, no? Yes? Okay. And even if you aren't a lifeguard, okay, where do you see that when you are talking about being a certified lifeguard? If you're talking about chest compressions, what does that have to do with this? What are you actually performing when you talk about that? Hopefully something you never have to do. Yeah, CPR, that's right. So this is that first part, okay, the C. The P is what, do you know? Latin for lung, I believe, is pulmonary. At least I think that's where it comes from. So cardiopulmonary resuscitation. But in this case, we're talking about the heart, okay? And then this, if this were talking about a vascular surgeon, what would they be doing as a vascular surgeon? Working on what, do you think? Because this is really, really vague because there are 5 different ones of these. That's what makes it so vague. Because when you say heart, that's right. And we talk about system, that means you have a whole bunch of structures working together, which you do. But what does the heart do? It pumps what? It pumps blood. So then how does that blood get to and from the heart? Okay, that's one. You said veins. There's 2, arteries. See, this is where there's 3 more to go because that's what you would have learned in elementary and middle school probably. Arteries and veins, and that makes sense. But as blood travels away from the heart through arteries, it gets to smaller arteries called arterioles, okay? Then what is the link between arteries and veins? Because it goes arteries, arterioles, these, then venules, small veins, and then veins that actually bring blood back to the heart. But it's a type of vessel that is really, really thin. And we know that because if you, for instance, like over the weekend, I was putting something back in a drawer, and right along here, I don't know if you can see that, I gotta get it closer, there's a cut right here, okay? So it did not bleed because it must have missed all of these. Certainly not an artery, certainly not a vein, because it's something really, really small, this type of vessel. Starts with letter C. You know the answer, you just don't know you know it. You say, I knew that. Yeah, capillaries, that's right. Okay, because when you, for instance, are unfortunate enough to break a vessel in your skin, that's when you start to bruise. Chances are it's probably a capillary, okay? And when it comes to unfortunate breaking of the skin and blood coming out of the body, which is worse when it comes to trauma of the body, an artery or a vein, do you think? And neither one of them are good, I know, I get that. But you got a 50-50 chance. I wouldn't expect you to know the answer, but why would an artery be way worse than a vein, do you think? It's not that it holds more blood, But who would have higher pressure? Arteries have much, much more pressure, okay? So that's why it'd be much worse if an artery is cut rather than a vein, because if it's a vein, it's just going to seep out of there. But when the pressure is much, much higher in artery, which it is, every time that heart contracts, it's pushing more blood through there, where with veins, it's just more so flowing through there. It's not being pumped as much because the pressure just is not as great. Okay. So as we move on, the most basic structure when we talk about the cardiovascular system then is that of the heart. Okay. So just like what we talked about when we're referring to structures that carry blood, okay, there are 5 of them. Okay, here's 1, here's 2. There's what links oxygenated and deoxygenated blood. So there's number 3. Here's number 4, and then the largest diameter veins, or what returns blood back to the heart, are the veins then. So when we said, as far as neither one of these are good, whether this gets severed, you definitely don't want this to happen, because what do you suppose it means when it says forces blood through? The reason it's getting forced through there is because the pressure is much, much higher. But the human body has a way to combat this. Okay? And what we mean by that is for any time that you have a sore or a scab, and some of you, I know, you probably pick at it. I'm just going to pick on you and just say you're picking at that scab. If it starts bleeding, why did that scab get there in the first place, do you think? Because how does blood stop flowing outside the body? Like, for instance, how many of you had donated blood over a week ago? It was probably you 2, okay? You 3, or 4 or 5, whichever, okay? The first thing, what's your perception on what is the worst part of donating blood? Usually it's the same answer, and I think there's something to that. What is possibly the most painful part of donating blood? When they're testing for this, I think, and maybe that's just because people told me that, now I got that ingrained in my mind. When they test for iron, how do they do that? Right. So when we say that's so painful, maybe, why does it hurt more when they take this, if you want to call it a needle, and then I don't know if it's your index finger or middle, any one of these fingers, okay? So in shoots that needle. Why does that hurt so much more than that 16 gauge, I think that's what it is, sticking into your forearm? Yeah, you have way more nerve endings in your fingers, so it's certainly going to hurt more. But whether the iron test is done or your donation is done, when you are actually going through the donation process, you've got that large needle in around the anterior part of your elbow, okay? All right, so what is it that you do to somewhat force that blood out of there? Something in your hand. Isn't like a rubber ball inside of a latex glove or something like that? So when you squeeze that, okay, your muscles are contracting, and that keeps that blood flowing, because once they pull that needle out, okay, what do they put on top of there or your finger? Cotton swabs or cotton balls, does that sound right? Okay. Then once you start pressing that cotton ball down on where you donated blood, that's eventually going to do what? You don't have to keep that bandage on. You can take it off in about an hour. How's that possible when you had what's somewhat of a significant hole there to donate blood? How is that possible that blood just does not keep coming out of there? Yeah, it clots. There's clotting factors in your blood. Okay, one of them that you this is a big foreshadowing. I mean, this is a ways down the road. What the seniors are talking about, okay, this might look familiar from biology, but when you start talking about these codons, each codon is a specific amino acid. These amino acids are structures like this, okay? And thrombin is certainly a protein, so it would have a various number of these amino acids linked together, because amino acids are building blocks for proteins. Okay, so thrombin is one of those proteins that works as a clotting factor. Okay, so you keep a little bit of pressure on there, and eventually those clotting factors start to form a mesh, and then that mesh starts to wrap itself around the skin. And then once that mesh dries, then what do you call that? Starts, we said, something that you pick at. It could be a scab. And then if you leave it alone, that scab will just eventually fall off. But some people, is anyone guilty of that? You pick at scabs and, okay. But anyway, but that's what's happening. You have clotting factors inside your blood. But when you have much more pressure in there, like you do with arteries, it's harder for that to stay clotted. But if you have a bandage that's big enough and you put pressure on there, that clotting reaction is going to start. Okay? Because even when you see, for instance, if there's blood on the basketball court, volleyball court, if there's drops on there, those drops are going to start drying in a matter of minutes, just because it's a process called coagulation. And what happens is those clotting factors inside are starting to react and starting to form that liquid blood more so into a solid. Okay. So I want to do this one. And then we'll finish with double circuit, and that'll be it for today. Because we are at about 12 minutes, so I know some of you will be tuning in a little later. So we went from arteries to arterioles, then to capillaries, which are one cell layer thick, to where gas exchange can take place and nutrients can be delivered as well. And that process, of course, is called diffusion, to where molecules like blood gases move from an area of higher concentration inside the blood to an area of lower concentration. The different cells that are getting delivered, whether it's those materials, whether it's muscle cells, you could say nerve cells, any one of those that need oxygen, it's going to diffuse through that capillary. And then as the blood continues on through venules, then eventually back into veins, which are the largest deoxygenated vessels that returns blood back to the heart. Trick question. Are all arteries red? Probably not, because we said it's a trick question, right? But that's a general rule of thumb, that arteries carry blood away from the heart. That is true, but not all arteries are red. Can't be, because of this double circuit, and we'll explain that in just a moment. Okay, and then we'll wrap this up here. So the pulmonary circuit, there that is. Remember CPR. Pulmonary means lungs, because that's where it's going to. So gas exchange can take place. Then the systemic circuit just means the rest of the body, where these nutrients are going to be delivered, and blood gases. So you don't have to draw this once we get this up. It's just something to aid in our explanation of that. I guess you could also look in the book, but then what fun is that, where you can make fun of, your drawings are terrible, and that's fine if you were to say that. But very quickly, does everyone have this information that wants it? Okay. So what we're talking about is as follows. Okay. So we'll try to make this anatomically accurate. I mean, that's not the human heart. This is Valentine's, right? If you want to call it that. So, well, even that isn't symmetrical, but the human heart probably more so might look some more like that, kind of like an apple. So, with what you know about the heart, does it have 2, 3, or 4 chambers in it? It does. Okay? So what that means, you're going to say, well, that's really, really odd. Shouldn't that be symmetrical? Shouldn't the heart have equal sized chambers in it? And the answer to that is no. Okay? Now the tricky part about this is, okay, since I'm standing and looking this direction, we're all oriented the same way. Okay? These are what we're talking about. Oops. Okay? So, what type of chambers are on top of the heart? Ventricles or atria? So it's atrium. We say atrium because that, or atria, which means plural. So what of these 4, so we know one of those 2, which one's going in here?
Just a reminder that all National Honor Society applications must be turned into Mrs. Milbrand by the end of the day.
Okay, so how are we going to label this part right here? Left. I mean, this is our right side. Why are we saying left? Because remember, you're looking at a mirror image. Okay? So that's the left atrium. This is the right atrium. This is the right ventricle. This is the left ventricle. Okay? Now, these would be similar in size, which you can actually see. But why is this side so much larger? Is that did the man upstairs make a mistake when he designed us? Or whether you say as we progressed as individuals through an intelligent design? Still an answer, why is this so much larger than that? You got to remember, there's 2 circuits, right? There's a pulmonary circuit. And then what was the other one? Systemic, or yeah, I suppose systematic circuit. Where is blood going when it leaves the right ventricle? It doesn't have much oxygen in it. So if this is deoxygenated blood, which it is, where's it going to go for blood exchange, for gas exchange? The lungs. Okay? Where are the lungs sitting in reference to your heart? Is that a long ways for them to travel? No, of course not. Okay? You actually have one that sits about right there, and one you could say sits about right here. This pulmonary circuit doesn't have far for that blood to go. But the systemic circuit, this has oxygenated blood. Where's that going to go? Brain, arms, rest of the body, legs. This has a long way for that to go. So, since it has a longer way for that to pump, the workload on this side is much more than it is on this side. So that's why this side is much larger than that. So we'll continue with this tomorrow. We'll catch up to you next time.